Hello, today I, Mitchell Jiam, will be presenting Chapter 4.1 and 4.2. In Chapter 4, the first topic will be radian measure. The general formulas for this chapter will be theta equals to r over radius, r equals to radius times theta. Theta is the radian measure. One complete revolution, which is 360 degrees, equals to 2 pi. Next, when converting radians to degrees, 2 pi radians equals to 360 degrees. 1 radian equals to 360 degrees over 2 pi. So after simplifying, you just cross out the numbers. You get 1 radian equals to 180 degrees over pi. For example, when converting pi over 4, we just take pi over 4 times 180 degrees over pi. After simplifying the equation, we get a value of 45 degrees. When converting degrees to radians, 360 degrees equals to 2 pi radians. 1 degree equals to 2 pi over 360 radians. After simplifying it, we get that 1 degree equals to pi over 180 radians. For example, when converting 60 degrees into radians, we just take 60 degrees times pi over 180. After simplifying it, we get a value of pi over 3 radians. Now let's do a question, shall we? In this question, Marcus decided to ride on the Eye of London. His capsule is located 15 meters from the center of the Ferris wheel. If the Ferris wheel turns through an angle of 4 pi over 6, determine the length of the arc traveled by Marcus' capsule to the nearest tenth of a meter. Referring to the equation above, we know that r equals to radius times theta. So, in this question, we know the radius is 15 meters and theta is 4 pi over 6. So after inserting the value, we get r equals to 15 times 4 pi over 6. After multiplying it, we get a value of 31.4 meters. Therefore, Marcus's capsule traveled approximately 31.4 meters. Time for another question. In this question, Nicholas flies a fighter jet during the war. The engine of the jet rotates at 8,800 revolutions per minute. Determine its angular velocity in degrees per second and radians per second. When calculating the degrees per second, we take 8,800 times 360 degrees. That will give us a value of 3,168,000 degrees. Calculating its angular velocity, we take 3,168,000 degrees divided by 60 seconds. That will give us a value of 52,800 degrees per second. Therefore, its angular velocity of the fighter jet is exactly 52,800 degrees per second. When calculating the radians per second, we take 8,800 times 2 pi. That will give us a value of 17,600 pi radian. Its angular velocity, we just take 17,600 pi divided by 60 seconds. That will give us a value of 293.3 radians per second. Therefore, its angular velocity of the fighter jet is approximately 293.3 radians per second. That is chapter 4.1. Next chapter is trigonometric ratios and special angles. There are 6 trigonometric ratios. 3 are primary trigonometric ratios, and another 3 is reciprocals of the primary trigonometric ratios. Among the primary trigonometric ratios is sine theta, cos theta, and tangent theta. Sine theta equals to opposite over hypotenuse. Cosine theta equals to adjacent over hypotenuse, and tangent theta equals to opposite over adjacent. The 3 reciprocals of the primary trigonometric ratios are cosecant theta, secant theta, and cotangent theta. Cosecant theta equals to 1 over opposite over hypotenuse, which is opposite hypotenuse over opposite. Secant theta equals to 1 over adjacent over hypotenuse, which is hypotenuse over adjacent. And cotangent theta equals to 1 over opposite over adjacent, which is adjacent over opposite. Next is special angles. Special angles consist of 45 degrees, 60 degrees, 90 degrees, and so on. In this triangle, there are two angles that are 45 degrees. It's a formula that when both angles are 45 degrees, the opposite is 1, adjacent is 1, and hypotenuse is root 2. 45 degrees can also be written as pi over 4. In this triangle, there are two degrees, one which is 60 degrees and another which is 30 degrees. The opposite of the 60 degrees is root 3, the adjacent is 1, and the hypotenuse is 2. Whereas the opposite of 30 degrees is 1, adjacent is root 3, and hypotenuse is 2. 60 degrees can also be written as pi over 3, and 30 degrees can also be written as pi over 6. The next one is the unit circle. A unit circle is a circle which has a radius of 1 all the time. In the unit circle, the line that lies upon the x-axis is the initial arm or ray, whereas the arm that changes due to the radian measure is called the terminal arm or ray. For example, when we have an angle which is pi over 3, which is 60 degrees, referring to the special angles above, we can determine that its opposite is root 3, its adjacent is 1, and its hypotenuse is 2. Therefore, after inserting the values, we get the triangle. Because the hypotenuse is 2, it is not a unit circle just yet. Therefore, we must times it with a figure that will make it 1. So, we take 2 times 1 over 2 equals to 1. But that doesn't only apply for the hypotenuse. We have to times both adjacent and the opposite. So, we take the adjacent, 1 times 1 over 2, we get 1 over 2. And the opposite, which is root 3. Root 3 times 1 over 2 equals to root 3 over 2. When calculating its cos, or cosine, cosine equals to adjacent over hypotenuse. Therefore, we have to insert the values, which is opposite of the angle is root 3 over 2. The adjacent is 1 over 2. And its hypotenuse is 2 over 2, which is 1. Therefore, when calculating the cosine, adjacent over hypotenuse, we insert the value adjacent, which is 1 over 2, and its hypotenuse, which is 2 over 2. Therefore, we'll get a value of 1 over 2. And when calculating the sine, sine is opposite over hypotenuse. So we insert the value of opposite, which is root 3 over 2, and the value of hypotenuse, which is 2 over 2. Therefore, we'll get a value of root 3 over 2. Did you notice that the x value here is 1 over 2, and the y value here is root 3 over 2? It's an interesting fact that x equals to cosine. The values are the same. And the y equals to sine, because the values are the same. Therefore, we can make a conclusion that cosine equals to x and sine equals to y. The diagram I am showing you right now is a more detailed version of the unit circle. We can find any point in the unit circle when given the angle. Remember that cos equals to x and sine equals to y, the one we learned just now. Therefore, we can calculate any given point of the unit circle. Now, I would like to briefly introduce the CAST rules. In the CAST rules, quadrant 1, 2, 3, and 4 has its own unique rules. In quadrant 1, all of the primary trigonometric ratios are positive. In quadrant 2, sine is positive and cosine and tangent are negative. In quadrant 3, sine and cosine are negative and tangent is positive. In quadrant 4, cosine is positive, whereas sine and tangent is negative. Let's do a question, shall we? In this question, Marcus is flying his kite at the end of a 50-meter string. The sun is directly overhead, and the string makes an angle of pi over 6 with the ground. The wind speeds up, and the kite flies higher until the string makes an angle of pi over 3 with the ground. Determine an exact expression for the horizontal distance that the shadow of the kite moves between the two positions of the kite. In this question, we have to sketch out a diagram to show the changes of the distance. In this diagram, pi over 6 is position 1 and pi over 3 is position 2. First, we must calculate the x of position 1. In position 1, cosine pi over 6 equals to adjacent over hypotenuse, which is x1 over 50, the hypotenuse. Therefore, we insert the values using special angles. Cosine pi over 6 equals to root 3 over 2 equals to x1 over 50. When finding x1, we throw the 50 over, so we get 50 times root 3 over 2. So after simplifying it, we get x1 equals to 25 over 25 root 3. In position 2, cosine pi over 3 equals to x2 over 50. Cosine pi over 3 equals to 1 over 2 using special angles. We can see over here. Pi over 3, cosine, adjacent, which is 1, over hypotenuse, which is 2. By finding x2, we throw the 50 over, we get 50 over 2. Therefore, x2 equals to 25. Subtract the x coordinates to determine the horizontal distance, d, that the shadow moves. d equals to 25 root 3 minus 25. By factoring it, we get 25 bracket root 3 minus 1. 25 bracket root 3 minus 1 equals to 18.3. We can find that value by typing it into the calculator. Therefore, the shadow of the kite moves approximately 18.3 meters. In this question, we must use the unit circle to determine exact values of the 6 trigonometric ratios for an angle of 5 pi over 6. First, we must sketch out the diagram. This is our angle, 5 pi over 6, and the remainder is pi over 6. Therefore, we draw a line and it falls on the second quadrant. First, we must find the x and y. Since x is cos, remember, and y is sine, we are able to determine the cos and the sine referring to the special angles. Since it's pi over 6, which is here, we just flip it over so that you can see better. The opposite is 1, the adjacent is root 3, and the hypotenuse is 2. Therefore, cos, which is adjacent over hypotenuse, is root 3 over 2. But don't forget the cast rules. Since it's on the second quadrant, only sine is positive. Therefore, we have to put a negative sign here. Whereas sine pi over 6 equals to 1 over 2. So we have to determine the 6 trigonometric ratios. To determine sine, it equals to y, which we calculated just now, which is 1 over 2. For cosine, is the value of x, which is negative root 3 over 2. Tangent 5 pi over 6 equals to y over x. So we insert the value of y, which is 1 over 2, over the value of x, which is negative root 3 over 2. We get the value of negative 1 over root 3. When calculating cosecant, cosecant is the reciprocal of sine, which is y. Therefore, we just put 1 over y. By inserting the value of y, it will be 1 over 1 over 2. Therefore, we get a value of 2. When calculating the value of secant 5 pi over 6, it's a reciprocal of cosine, which is x. Therefore, we insert 1 over x, which is 1 over negative root 3 over 2. Therefore, we get a value of negative 2 over root 3. Do not forget it's on the second quadrant. Since secant is a reciprocal of cosine, therefore it's a negative figure. The reciprocal of tangent is cotangent. Cotangent is 1 over tangent, which after we put the value of tangent, which is y over x, we know that cotangent is actually x over y. So when calculating cotangent, we insert the values of x first, which is negative root 3 over 2, and the values of y, which is 1 over 2. Therefore, we get a value of negative root 3. That is the end of chapter 4.2.